Hello, this is Mr. Huff, and I want to talk a little bit about some specifics on aircraft control and some of the components that make up an aircraft. Through your assignment today, or through the assignments you have this week, I should say, you are going to be able to build up some vocabulary as far as what the parts of an aircraft are. So make sure that you find really great, unique pictures and label them appropriately. One of the things I want to point out about a winglet and why they're necessary, these are passenger planes, and you'll see that at the end they have these little tilted up wingtips or little fins on the end. And what this does is it disrupts some drag that occurs at the wingtip to make it more efficient. So the wing produces more lift more efficiently, and that cuts down on fuel costs. In the commercial airline industry, it's all about reducing fuel costs because that is the single most expensive thing in running these planes. We need to think about the center of gravity. Those of you who were in principles of engineering, you probably remember talking about this, where you found the center of gravity. It's the geometric center if the object is uniform in density. For an aircraft to work properly, the center of lift from the wing and the center of gravity need to be aligned. If they are not aligned, the flight will not be stable. So you want the center of gravity, which is indicated by this symbol here, to be lined up with, vertically with the center of lift. If they are off from each other, you will not have stable flight. And what stability means in flight is if you have an updraft, it causes the plane to go up here and it will oscillate, but it will eventually return to stable flight. There's a trade-off between stability and maneuverability, and I'm going to have you look at that. But generally, if you have more of one, you have less of the other. You will be explaining how the aircraft is controlled in these three axes, the X, Y, and Z axis, or the longitudinal axis, the vertical axis, and the lateral axis. This table in the presentation you're given is really useful to understand how the aircraft is controlled. I would really like to talk about forces in flight, but I think we're going to do that later. Right now, you just need to understand what the ailerons do, what the elevator does, and what the rudder does. There are some wing locations, so high wing, mid wing, and low wing. So with the high wing, you get very stable flight because most of the mass is below the wing. And then with the low wing, you get some turbulence over the wing, but you improve maneuverability. We'll talk more about tail draggers in a moment. With the mid-wing, it's kind of a trade-off. You get a little bit of both. You get some stability and some maneuverability, but there's also some turbulence over the wing. I want to point this out. When you see bizarre things on an aircraft like this, where instead of one rudder, they now have two or three, that means that the initial design did not provide enough control. So to improve control, they added additional rudders. This is mechanically more complicated and not an optimum solution. The better solution would have been to increase the size of the vertical stabilizer and the rudder rather than adding additional. I'm going to have you do a little bit of research about this aircraft specifically. Let's talk about these power plants. You have the tractor, which is what you think about with a normal aircraft where the engine's in the front, and you have a pusher where the engine is behind. The big advantage of a pusher engine is the wings have less turbulence because the force is behind the wing. With the tractor close to the fuselage, you get disturbances and turbulence along the wing, so it reduces the lift close to the body. I want to talk about the Oleo strut. Oleo means oil, so this is an oil-filled strut. So basically it's a very viscous fluid. So it acts like a shock absorber. Initially on impact it's very rigid, but it collapses slowly, so it smooths out as you go down the runway. Many of the first airplanes were built with flotation because it was easier to find a lake or a river to land on than it was to find a runway. So that solved a problem there. Let's talk about tail draggers for a moment. These have very large engines in the front. Consider the one at the top left. What that means for the pilot is when they're approaching runways, they have a big engine in front of them and it's very difficult to see. This was a problem when you wanted to land on an aircraft carrier, and this happened a lot in World War II. So what the pilots had to do, they couldn't approach in a straight line. They had to approach at an angle and bank right as they landed so that they could see that they were landing in the right place. If they had just flown straight in, they wouldn't have been able to see the runway on the carriers, and that was a problem. These are some interesting specialized landing gear on the rough field. These are shock absorbers so they can bounce up and down. And for soft field, you see very large tires so that it can bounce and move across the soft field without sinking and slowing down. And this last slide, it talks about the instrument panel. One of the design features that has to be really considered in the development of an aircraft and the control panel is it has to be easy to understand at a glance. If you have to search around and think about things, you have problems. Like in the space programs in the 60s, what they figured out is if you made the dials where when they were in the right place, they all made a straight line, it made it much easier to determine if there was a problem and where it was, rather than just having dials everywhere pointing any which direction. If they all lined up and one was out, you could tell you had a problem. All right, that's enough about that.